When the natural number line is ordered into a cycle of 72, some very special relationships emerge. The first order to note is where the square numbers occur within the grid formed. They all end up in 12 discrete columns. In all 12 columns, the squares contained within each individual column are described in order of rank to infinity by their own quadratic trinomial equation. The next order to note from this view is the columns that the prime numbers occupy. Although the primes are restricted to certain columns, their distribution within each appears random. There are 24 of these. The numbers seamlessly completing these 24 columns are multiples of primes, known as prime composites, effectively separating primes and their offspring from all others. What has now been formed is a coherent view of number that separates the natural number line into three distinct categories. 12 columns of squares, each structured by their own defining quadratic progression. Perhaps more importantly, the primes and prime composites are simultaneously locked into 24 columns. And the rest, the common composites, that if divided by 2 and or 3 until no longer rationally possible, will fall into either a prime composite column or conclude at 1. With this basic understanding, the mechanism behind factorization begins to emerge. Each prime composite column is composed through the interaction of two of the 12 square progressions. This is performed by the difference of two squares, using the two square progressions, giving the factors for every prime and every prime composite within that column. In practice, the following factorization would be performed algebraically. Visually represented, it is easy to see the power of the concept. Factorize 4794. First step is to divide by 2, which gives 2397. Now an odd number that cannot be divided by 2. Dividing by 3 gives 799. Dividing rationally by 3 again is not possible, so 799 contains all of the prime factors of 4794. Finding these prime factors is now simple geometry and a slide rule. 799 sits naturally in column 7. The two square columns that combine to make column 7 are column 16 and column 9 in the form column 7 equals column 16 minus column 9. Now for that slide rule. Offset the position at the start of the column being subtracted, column 9 in this case, to the same row as the number being factorized. The next step is to locate where the two adjusted square columns contain squares on the same row or cycle. In this particular case, they meet at 32 squared in column 16 and 15 squared in column 9. Now it's just addition and subtraction. 32 plus 15 equals 47, and 32 minus 15 equals 17. 47 multiplied by 17 equals 799. Following the squares to their conclusion in this case, they match up once more at 399 squared in column 9 and 400 squared in column 16. These two squares yield the result 1 and 799. This reveals an efficient roadmap for factorization once fully understood, and brings prime numbers into exclusive groupings that coexist with their hidden cousins, their prime composites, through the difference of two squares, always.